Hello, fans. Welcome to a review of special right triangles before we test. So today we are going to go over a few slides for you. We're going to do, the first slide is looking at the right types of right triangles and identifying the method based on the information that we have and what we're asked to find, what method we would use to solve the right triangle. So we'll go ahead and start with that. So the methods that we use to solve these triangles in this unit are Pythagorean Theorem, special right triangles, trig, and inverse trig. The Pythagorean Theorem ones are already listed here. I just sorted them for you guys to make it quicker. When you're given the lengths of two sides of a right triangle and asked to find the third side. So find the missing side, you're given two sides. Find the missing side, you're given two sides. Find the length of the missing side, you're given two sides. The inverse trig ones look similar to the Pythagorean Theorem ones because, again, you're given the lengths of two sides, but then you're not asked to find the length of the third side. You're asked to find the measure of one of the angles. What is the measure of the missing angle? What's the measure of the missing angle? But you're given two sides. So that's the difference between those two. Special right triangles are ones that are 30, 60, 90, or 45, 45, 90. And I'll do those for you right now. So I see a 45 degrees here, I see a 30 here, a 45, and a 60. What else? That one's got 40 degrees, and that one's got a 65, and this one's got a 32. So those are not special. These three left, what is the value of x? You're given the measure of one of the other angles of the right triangle. You're given the length of one side and asked to find the measure of another side. So these are going to be trig. How do we do on that? Thumbs up, thumbs down. Okay, good. All right, what's the next slide? 50. Slide number 50. Let's see what that is. Okay. This one is kind of difficult. It's going to be more difficult than I would give you on a test, but you would see something similar to this on your SOL, on your state test. And I ordered the lengths of the sides, A, B, C, D, so you would know kind of what order to go in. You're only given the measure of one of the sides. This is a 30, 60, 90 triangle, and this is a 45, 45, 90 triangle. So we know they're both special. This is the length of the hypotenuse because it's across from the right angle. We have memorized the relationships, and we know that half of the hypotenuse is the short side. This is the short side because it's across from the 30. Are you with me? So that A is just 5. Once we know that, the length of the long side is 5 square root of 3. Because the relationship between to go from the short side to the long side, which is B, is times the square root of 3. So it's 5 times the square root of 3. How are we doing? Okay, the last two, this is the 45, 45, 90 triangle. We know the length of the hypotenuse is 10. The relationship between the lengths of the legs, which are the same here, and the hypotenuse is times the square root of 2. So to go from the hypotenuse to the length of the legs, we have to divide by the square root of 2. There's not a lot of space to show you this, but I'll just do it right here. If I do 10 divided by the square root of 2, I'm going to have to multiply by special 1 to rationalize the denominator. When I do that, I get 10 root 2 over 2, which can be simplified because 2 goes into 10 5 times. So that's 5 square root 2. And they're both the same length. How are we doing? Good? Okay. Next slide, 54. This problem is a trig problem. We are given the measure of one of the other angles besides the 90 degrees. We're referencing this angle right here. This x is opposite. This 12 is adjacent. Opposite and adjacent, we have that memorized. That's tangent, the tangent ratio. The tangent of this angle, which is 28 degrees, equals opposite over adjacent. How are we doing? That's the hardest part. Now we have to isolate the x. So to do that, we're going to multiply both sides of the equation by 12. So I'm going to take out my calculator, and I'm going to do 12, there we go, 12 times the tangent of 28 degrees. And does it say to round? Yeah, round to nearest tenth. So 6.38 rounds to 6.4. You guys okay with the rounding there? Are you okay with the 6.4? 6.38 rounds to 6.4. Are we good? Am I going too fast? Was that a yes?
No.
Oh, okay. Next slide is 55. This is a special right triangle. Oh, there's two of them, right? This is a square. This diagonal is the hypotenuse. You just have to have memorized that the length between, or the relationship between the length of the legs, which are the same, so 45, 45, 90, and the hypotenuse is square root of 2. So it's the length of the leg times square root of 2, so it's just 5 root 2. No work. How are we doing? One more. 56, 56. Okay, the inverse sign of 4 over 5. This theta represents the measure of an angle. So if you see that instead of x, or if you see another variable, they use theta a lot for angles. Don't get confused, it's just we're trying to find the measure, or sorry, we're trying to find the inverse sign of 4/5. We already have the triangle worked out. So let's see, which triangle we're going to use. I'm referencing this angle theta. The sine relationship is opposite over hypotenuse. The opposite side for this triangle is 3. That's not it. Opposite side for this triangle is 5, 3, here we go, 4. Opposite over hypotenuse, 4 over 5. So this is the triangle we're going to use. And you would just, it's asking for the representation. I don't know why there needs to be any work there. So that's it. We're done. Questions? Going once. Going twice. Sold. Look at my fire volleyball t-shirt today. Can't see it. It's the one for this year. All right, guys. Thanks for coming out.